I want to get ready for inviting three of our amazing founders. We'll bring on Sandy from Scroll, Zac from Aztec, and Alex from Aleo. They're going to be talking about how we can make zero-knowledge proofs more practical, how to think about it for their chains, and overall, the things that we can be excited about in the world of ZK. So please give them a massive round of applause.
It's good to see it, Dawson.
All right. We have a pretty large service area here to cover. So we'll kind of decide as a group how deep we want to go in some of these things, or how many fights we want to have on stage. But that one's not going to be on me. That's up to you two collectively, you three. Developing frontier technology is not easy. We've kind of seen.
Nah, it's a piece of cake.
Yeah.
Trivia. Skill check.
All right. What did you think you'll be able to get done immediately, and the timings were off?
Ooh. Now that's I'm wondering how honest I should be about this one, because
let's try the 90%.
Spicy question. Okay, so honestly, privacy, privacy itself. So just a bit of a history stuff thing. Basically, in 2017, I wasn't the co-founder of Aztec. I was a co-founder of a company called Credit Mint, because we minted credit on chain. It wasn't a good name. And so it was a TradFi product that uses Ethereum to cut out some middlemen, use decentralization to get some better trust guarantees. But back then, in 2017, we were very naive, and I was kind of assumed, privacy, yeah, you can get that by just obfuscating transactions, splitting them up into little, packets, sending them around. As I said, I was completely new to the space. And we realized, okay, we wanted our clients to be these billion-dollar funds. They ain't going to be okay with their portfolios being splashed around on chain. And actually, chain analysis is a problem. There is no privacy. What do we do? At the time, I thought, well, Zcash has solved this, right? And the Ethereum Foundation made loads of noises about bringing Zcash to Ethereum, as in they'd added these precompilers. Someone was like, oh yeah, we can solve this. This is a solvable problem. And that was winter of 2017, and I'm still working on it.
Sandy, maybe I'll ask you for Scroll. What, as you were thinking about the zkVM, what did you think was something that's going to be easy, but turned out to be a much, much longer task than expected?
I would probably answer this question in a slightly opposite way, is that when we started off, we assumed this would be a very, very, very difficult task, building the zkVM. I think most people estimated the endeavor would take 10 years. And we estimated building a team and assembling ZK researchers would probably take 2 to 3 years, since it was very scarce, and we thought we would have to train up a lot of people, and to get trained as a ZK engineer would take a really long time. And I think we got very lucky along the way and found a lot of talent around the world, and that's made it kind of go to market a lot faster.
And finally, Alex?
Yeah. I guess my kind of immediate reaction is like Zac, is wow, where to start? Everything, I think, once you dig into it, is a challenge. But I'll maybe take the outside of the technical side. I think it's just developer adoption and applications that use zero-knowledge cryptography in a way that does something fundamentally unique, and seeing what those are. I think we're still, to this day, I'm certainly speaking for Aleo, applications for ZK are still theoretical, largely, right? And so it's helping create a developer ecosystem where people grok this slightly different paradigm enough to be able to leverage the power that this type of cryptography gives you. That I think itself, is hard, because you're talking about a different model.
I feel like we've kind of brought up these themes already. So there's in a way, when somebody looks at ZK, you can partition that into a bunch of kind of high-level buckets. There's privacy, there's scalability, there's compute. They're obviously very overlapping with each other. Maybe my kind of first question would be for Sandy. How do you think about ZK for scaling, and sort of what was the goal behind starting Scroll? And for our audience, let's also understand a little bit about how Scroll works and just overall how it's architected.
Yeah, sure. I think how I started was that I've been kind of in the Ethereum space for a while, and I was a crypto investor before, and I've been quite getting deeper and deeper into the Ethereum core research rabbit hole. And I think the scalability problem has always been a kind of a problem. It's been there for a few years, and everybody understands there's a massive on-chain proving overload. And the aha moment for me when I met Ye. He was a first-year PhD student, and he had a paper on hardware acceleration. And for me, I didn't realize at that point that hardware was mature enough to process some of these proofs and package it to a way where it would be commercially competitive and also essentially make Ethereum very accessible to a lot more people. And so we thought this is a very worthwhile mission because Ethereum has found product market fit, and it has a lot of use. It has the potential of bringing financial inclusion to everybody that wants to participate in the network. And we think more people around the world deserves to kind of be a part of this community. So that was part of the mission and part of the why we embarked on this journey.
And Alex, you're kind of effectively with Zexi betting heavy on compute. Tell the audience kind of what the intuition behind Aleo is, and kind of how do you intend some of the new complex use cases to be?
Yeah, so Zexi is a paper. Is the name of a paper that kind of describes an extension of the model of Zcash, right? So Zcash kind of pioneered private payments in Bitcoin, and Zexi kind of tries to extend that in the direction of Ethereum, right? Which enables kind of smart contracts, right? Is the high level idea. So Aleo implements Zexi. Now, I think actually in the beginning, we looked at doing Aleo as a layer 2 on Ethereum. And one of the reasons why we decided not to was because the Ethereum virtual machine, the way it's kind of architected is general. It's not specific to this use case. And to implement Zexi in a way that's performant and efficient, you kind of need to, in a relatively bespoke manner, kind of purpose build all of the different pieces from the ground up if you don't want very expensive, proving or verifying in terms of, gas costs or just real world time. So that's why we ended up embarking and going out in a different direction and saying, hey, we really believe privacy specifically is important, like, for different use cases like identity. So that element of ZK, the zero knowledge, I guess, snark being kind of the part where it's succinct and therefore scalable, like the ZK part is what we really focus on for real world use cases. And that was the motivation behind Aleo. Now, of course, like Aleo itself is a platform for privacy preserving computation. So that's how we look at it.
Could I be slightly spicy here?
Ooh,
in the most respectful way.
Everyone look up from your phones. It's about to, gloves are coming off.
So you mentioned that, one of the reasons you decided on the L1 pattern was because the Zexi protocol it's not easy to implement on Ethereum. It becomes very expensive. I think that was true when Aleo got started. It's not true anymore. As in, because since Zexi was published, we have these sort of half-pairing friendly cycles where you can use Halo 2 style recursion techniques now and folding schemes and God knows what these days, to basically crush the problem down to something which is trivially solvable, to the point where, for example, Aztec is our architecture hasn't really got a name yet, but it's very much we see it as an iteration of Zexi. Certainly, the Zexi paper was a very seminal paper where we got a lot of the ideas for how one could architect a ZK system.
I think,
you can get that kind of stuff on Ethereum these days.
I think so. To me, I guess it's really important though to define specifically what are we comparing to, right? I think the architecture that I think you guys are building, it sounds really promising and interesting. I think we'd have to see concretely for different applications how they compare in terms of all of these costs, right? And what assumptions are you making? For example, I think one thing that I personally, I take issue with at the definitions of crypto layer 1s and layer 2s is I think sometimes inside of this stack based framing, we introduce new assumptions around the permissionlessness of technology. I'm not saying this is the case for anyone necessarily, but I do think it's not quite apples to apples anymore when you're talking about, a layer 2 and a different layer 1, where it's from the permissionless standpoint, for a user perspective, it's a bit of a different experience. So I think at a high level, I agree with you. It's possible. I think concretely, I think we would just need to compare things apples to apples and have an academically rigorous conversation about what is a fair apples to apples comparison.
What is an apple?
Well, so I mean, Zac, I think you've kind of been on the L2 side before. You've explored zk rollups and I guess the iteration that Aztec is now. So maybe kind of tell us about sort of what that evolution was, and let's contrast that with.
Yeah, sure. So why is Aztec and L2? Well, I guess we kind of came to it from a different end, where because we were like an evolution of a protocol that was building on Ethereum to begin with. We had, I guess, maybe more of a the way I see it, like my approach to like developing zk tech in this space has always been that from the perspective of an engineer and not a cryptographer. As in, I'm wearing my engineering hat and thinking, okay, imagine when it comes to cryptography, imagine I'm a smooth brain. I know nothing. I don't want to know anything. It's complicated. It's messy. I just want to write private smart contracts. I want to do like Ethereum-like things with private state. And Ethereum was a natural home to put Aztec on for several reasons, mostly around greed and laziness. But alignment. So what is Aztec's core competence? It's cryptography. It's developing advanced cryptography, taking it from research to production, and then building out products and services and infrastructure tech that uses it in a way that's accessible to engineers. We are not domain experts in distributed consensus. We're not domain experts in the technologies, the technology stack that's required to build an L1. So we were like, we don't want to. We want to cut that all out of our protocol, inherit that from someone else who's already done all the hard work so that we can focus on our specialism. That's the laziness part. The greed part is, why is privacy useful? If I gave everyone here magic beans, and you started trading around magic beans, do you care about hiding how many magic beans you own? No, because like no one cares about your beans. So no one cares about your like privacy or transparency. For privacy to be useful, you need value, you need liquidity, and that is on Ethereum at the moment, overwhelmingly. And so to make Aztec most accessible, like to make Aztec's unique value proposition, programmable privacy, as accessible as possible, we want to be sited as close to that liquidity as possible, which means building an L2 on Ethereum.
I guess, though, back to that point, I think you talked about not being an expert in distributed consensus, but to have an L2 that emulates Ethereum's functionality, don't you need to figure out how to manage state access concurrently, right? So you need to have some kind of, you either need most L2s today do, there's a sequencer that just manually orders transactions, right? And that's a new assumption around permissionlessness, right? Now there's a new party that exists that you have to add an assumption about, that now it's now no longer quite the Ethereum model, right? And is that bad or good? I don't know, but it's different, I think. So I guess, like, how do you think about that in that sense?
Yeah, it's different, but it's also, I wouldn't consider it part of like the consensus model. I see that as the state model, and that's my wheelhouse. That's my jam. Basically, like, how do you create a useful privacy preserving application? It's tricky because take a Uniswap or pretty much any DeFi protocol. You're going to have global shared state variables. For Uniswap to work, you need to know the total amount of value in every single pool so that you can do price matching. In a privacy-preserving world, every state variable is encrypted because it's owned by somebody. It's private, or maybe a small group of people. So how do you get global shared state? Well, you can't. So then the question is, well, what does that mean? Privacy is useless? Well, no, but it means that, like, our strong conviction is that for useful privacy-preserving applications, you need a hybrid state model. You basically need the ability for individuals to own encrypted states. So that could be like tokens that or it could be NFTs, or it could be like information in a smart contract that defines your identity, where that's all encrypted. You're using zero-knowledge proofs to proof statements about it, but that can be connected in a very composable way with more transparent protocols like Uniswap, where you need that public shared state to for the protocol to work. To give a concrete example of how this would work, take an AMM on Aztec. Well, the AMM will be public, so the tokens going through it, the prices, the orders, that will all be public. What will be private is the identities of the individuals that are participating, and any kind of logical checks and balances that were applied to validate whether that user can participate.
Yeah, and we have a public-private model as well, but I think still it doesn't solve the problem of, like, I trade first, you trade second. How does that actually settle on the layer one?
Yeah, so that's MEV, as in, and I think it's L2s inherit the problem from L1, as in you still have the same issue with L1. So take Ethereum, right? I'm a validator. Great, I get to make the next block. Well, I get to build the block, which means I can order transactions however I want. I'm going to order them in such a way that I'm going to be able to extract the maximum amount of value. Does Aztec solve this? No. At least when it comes to the public state part, our sequences have exactly the same problem. But that's not our problem to solve. I'm very confident that issue is better tackled by the community building on top of these networks than actually at the protocol logic, in the protocol logic directly.
I have a question for you two. This is something I've generally not really thought about because I'm
great. I can be on Twitter.
Taking over your job. Kartik.
Introducing Sandy, other moderator for panel.
So if I'm a user who really cares about privacy on chain, what should I be thinking about when I'm thinking about choosing whether an L1 or privacy L2? What are the differences in the trade-offs?
Yeah, I think, I would love to get to a world, where, and honestly, just because I got into this, maybe just let me just take a step back. I got into this space working on the Syrian-Turkish border with Syrian rebels, 7 years ago when I was still in the U.S. Army, and a lot of those people were refugees, right? And so I have a very keen understanding of how, a subset of the population, actually maybe a large majority of the world's population, is cut out from things that we all take for granted, right? And I think that's just one example of a specific. So to me, I want, that's a population for which privacy is important, right? And even beyond that, how many people in this room take their paycheck in a stable coin? Okay, yeah, it's
very few.
That's about right, right? And this is answering the question that's not necessarily being implicitly asked, which is why is privacy important? Well, that's why, right? Because we don't even use, for the most part, our own products because they don't have privacy, right? And I think privacy is an essential part of the UX. I would hopefully, whether it's Aztec, whether it's Aleo, whether it's any of Zcash, hopefully at some point, these things are just abstracted underneath a bunch of other layers, and people don't even think about it, right? In the same way, I don't think about the stack that enables Apple Pay to work, right? I don't even really think about how my phone works at that point. So I think for I actually don't like the framing of users choosing the L1. I think it's developers who build applications that solve a problem for users. And I want to enable developers to have the tools that they need to do that. And that's, to me, the biggest challenge. That's why I mentioned it first when you asked the question.
Yeah, I think I'm mostly in agreement there. If I'm talking to a user about L2s and L1s, I've already lost. What matters are outcomes. What can I offer a user? Can I make their lives easier? Can I provide them high quality financial services? Can I give them a bank account in a developing country? Can I help them coordinate with their peers, perhaps in some kind of pseudonymous whistleblowing application? If I've got to talk about L1, L2's distributed consensus, that doesn't matter. That's the implementation detail.
I think it matters to the extent that it has an implication for what types of apps you can build, right? So this is why sometimes I harp on this concept of permissionlessness, right? Because I think permissionless software, I think that's what makes blockchain special, right? Is the fact that anyone on this stage can deploy a contract to Ethereum right now, can use Ethereum. That's it. No, I don't need anyone's permission, right? Bitcoin, same thing, right? So I think, to me, that's the key piece. That's why I focus on a lot. That's one of the other reasons why we went the L1 route, because it's the closest you can get to permissionlessness, which I think then enables different types of applications which are new and novel, right? And I get that's where kind of everyone is going at the limit. But to me, I think it's something that we sometimes can lose sight of. And I just want to make sure that, for me at least, we stay very focused on that outcome.
I feel like that this L1 versus L2 thing seems only relevant until we kind of get to a point where liquidity is not as fragmented, which means I kind of need to know, do I have an asset on this chain to be able to actually interact with it? But that's a secondary piece that someone else also gets to kind of control or improve. But I largely agree with your points. I think that's fair. So maybe let's flip that conversation on kind of the other group, which is effectively this is important for, is developers. In the case of Scroll, I just have to write my EVM contract. If I was a Solidity developer, that's excellent, which means I just have to be willing to deploy on Scroll if I already have a mainnet contract. Are there any other benefits to kind of picking Scroll and sort of, or I guess future upgrades that they can get for the benefits of kind of actual ZK encryption there, or just any ZK enabled primitives? I'll start with that, and then I have similar questions for why Noir and Leo.
Sure. I think the way developers can interact with Scroll today is whatever you've been building on Ethereum mainnet for the last couple of years, whatever you've been running, deploying on Scroll is just a copy and paste kind of job. And if you've been learning Solidity for the last few years, your learning will not go to waste. You can still continue using exactly the same things without having to re-audit or retool anything. Our current product is trying to maximize Ethereum compatibility to the largest kind of technically feasible extent so as to make the developer's job easier. And to me, that is the kind of the biggest opportunity for L2 because Ethereum has already found product market fit, and not many products in the world have done that. And we're kind of an extension of Ethereum in terms of its technical roadmap. But going forward, there's actually suddenly a lot of options available to us now that we have a working product. And there's certainly a lot more options. So there's a long way to go in terms of improving security. There's also a long way to go in terms of kind of increasing efficiency, so like making it cheaper and faster. And there's also a long way to go in terms of decentralization. But I think the first instance is really important because developers can now use it, and we can start kind of getting feedback from developers about what they need. And we've been live for about a month now, and I think we've hit 3 million users faster than any L2 in history.
Amazing.
Thank you. We're very proud of that, and I think I think most importantly that the feedback for us have been very real, and also some of it has been expected and some of it somewhat unexpected, but all of it is super useful in terms of helping us shape our priorities for the next kind of couple of months and years.
I'll kind of preface it by saying I know that's not an actual choice that you made, I think, but it was never like, let's not focus on zkEVM or just making everything on Aztec or Aleo EVM compatible, but kind of walk us through like why was there a need to create a brand new language and kind of why that had to be done and what kind of benefits there were for this path.
Yeah, sorry, I mean too. We go ahead. Yeah.
So I think I don't think it's helpful to talk about a language in isolation because every language is kind of intrinsically linked to one or more execution environments, as in the place where you're going to deploy programs written in your language where users are going to be running those programs. So for example, for JavaScript, the language, its execution environment, one of them is Node.js. For Solidity, its execution environment is the Ethereum virtual machine. What is Aztec's execution environment? Well, it's the Aztec layer 2 and the Aztec network, and it's a weird one because we have private state that's encrypted, owned by individuals. It's a very unique, novel execution environment that does not yet exist anywhere else in the world. Present company excluded, accepted. As in, you just don't have any existing like heuristics or paradigms to base your environment off of because. If you have private state, your state model it's atomic UTXO based. Updates have to be atomic. You can't modify state. You can only delete it or create new ones. And then you need to compose this with a more standard account based database. So the semantics around how to actually construct transactions that can modify the data structures is completely novel and does not just exist outside of the projects that are trying to crack this on Web3. So we're like, okay, well, the execution environment is unique. The transaction semantics are unique. The language semantics need to be structured to make this as easy and convenient for developers as possible so that we can try and create these abstraction layers that map these relatively unfamiliar concepts to more familiar concepts, which meant that for the language, we wanted to be able to very strictly control its semantics so that we could be very opinionated about how to do this, which meant, well, it means we need a new language. So that's why we came up with Noir.
Yeah, I think Leo is. I think that what your answer applies equally to Leo, right? I think it's large parts because it's a new paradigm. I think the one other thing I would say is like there are languages that actually predated both Noir and Leo for ZK, right? Socrates was one of the early attempts, right? It's this idea of like you could synthesize a circuit using a high level language for Ethereum smart contracts.
It didn't have a state model.
It didn't have a state. Well, its state model was kind of implicitly Ethereum, I think, in the Socrates case, right?
Yeah, which is not the state model that
Yeah, I guess
Right.
We use
it's
all
the
use.
private and the public.
Right.
piece. Yeah.
But nonetheless, the reason I bring that up, I want to focus on a slightly different aspect of what Zac said, and part of that is just like, you're talking about zero knowledge cryptography. We're talking about doing computation and then doing it in a privacy preserving way. Like that has overhead, right? Overhead in a number of areas. Like one of the common ways we measure overhead is a constraint cost, right? Which you can kind of think of like as a cost for executing a given program, right? And if you have a compiler, so, language, like I agree with Zac, everything he said around, it's like you have your execution environment, you have a compiler that you take, high level logic into like, your execution environment, doing that efficiently can make a huge difference at the end of the day for performance and cost, right? And I think that's the other aspect of it. And then the last thing I'll say, maybe just less on the technical side, more on the developer adoption side. I used to be in VC as well. I was a partner at A60Z in the first crypto fund. And I remember in 2019 when I started, people used to say about Ethereum, they're like, oh, no one wants to learn Solidity. Everyone already knows JavaScript. In fact, I don't know if anyone in this room, if it's been around for a while, remembers there used to be this project called EWA. It was EWASM? I think it was EWASM, right? It was like the idea was like, no one wants to learn Solidity. They're like, so we need to figure out how to port like people, other people writing from other languages. And that now is, of course, kind of defunct, right? And now the new narrative is like, well, Solidity, everybody already knows. And at the end of the day, Solidity is a good language for what it is, right? And we're trying to build Nora and Leo to be good languages for what they are. At the end of the day, developers, my view, like developers don't want to learn a new language. It's not like they don't want to learn a new language. You just have to give them a reason to learn a new language. If there's a reason to learn it, whether you're a developer or not, you're going to invest the time on it. But if it's just for no reason, well, no one's going to want to spend their time to do something for no gain, right? But I think in this case, in this model, the only way you can get privacy preserving computation because of the different programming model that Zac mentioned, I think you can't really just take an existing paradigm, at least if you want to do privacy preserving computation in a permissionless way.
So, I mean, maybe for Zac and Alex, what do I need to, how do I update my thinking around what composability would look like in this scenario? For the case of something like Scroll, it's kind of obvious. We know kind of how to interface because everything is on the EVM. But if you ever wanted to be cross-chain compatible or even kind of EVM adjacent, does that break, or does that mean only certain things are possible, or maybe what's not possible? What does that kind of feature look like, or did you make that trade-off saying, oh, look, we're not going to worry about composability just yet?
Well, we care greatly about composability of contracts within the Aztec network, not necessarily cross-chain. As in, could you transpile EVM, like Solidity contracts to Aztec contracts? Well, yeah, if you didn't want privacy. But if you don't want privacy, yeah, I mean, why are you using Aztec? To be honest, it's... we've made some very distinct trade-offs, which mean that if you just if you just don't care about privacy at all, then you're going to get cheaper transactions elsewhere. We care about intra-network composability, and that was extremely important for us. Composability. That is, I want to write a contract. I want my contract to be able to call other contracts, and to do this in a completely permissionless way, and that's very tricky in a zk context. Again, like I looked at the problem starting from an engineer. Like I want to be able to literally like write a contract in Noir with functions. There's functions to call other functions in another contract, and that a transaction can be an arbitrarily long sequence of function calls. And that is, as Alex may agree, is an exceptionally difficult problem. But for us, it was important to solve that so that we had our intuitive developer experience. And so the way that Aztec does it, we have private and public functions in Aztec contracts. A private function modifies as private state, public functions modify public account-based state. Private functions can call public functions, but not vice versa. Like those are the heuristics, and there's lots of reasons behind those heuristics, but the idea is we want to hide that away. And then we use some rather mind-bending
Moon map.
psychologically disturbing techniques to make that all provable within a web browser through like heavy use of zk recursion. But yeah, that's I think we'll see when we go live in mainnet. But I think we've cracked the problem of like composability of contracts within the Aztec network. Across different networks, that's another story.
Yeah, and we have a similar paradigm. So I think, like public-private, I'm not going to dwell on that as much. I think I'll maybe just mention that I think composability cross-network I think that's one nice. I think one cool application for zero knowledge is you can have. I think it's almost it's a better or more secure paradigm for Oracle generally, right? I think not only can you potentially interface with other networks like Ethereum, and how would you do that? Well, you can prove. You can basically prove the latest state based on a state transition function of like another blockchain inside of the Aleo network. This is kind of how bridges work generally today, right? The addition here is that you have a cryptographic proof that, so in some sense is more secure than the multi-sig way we do it, right? But in addition to like having cross-state or state move between blockchains this way, you can connect to like real-world systems that use cryptography. Like one project that I think is criminally underrated that I recommend everybody check out, it's actually, I think, an Ethereum, an ETH Foundation grantee, is TLS Notary, right? There's a bunch of little examples where you can take like, anything that has it uses TLS or a signature from the regular web, and you can verify that on Ethereum. There's like really cool ways where zero knowledge can be used to interact with the real world. One project that we have built internally to kind of show this is something called ZPass, which is actually an implementation of a paper called zkCreds. And part of that protocol requires you to verify a signature of from a issuing authority for your passport, right? So you're basically digitizing a passport, and in that process you're verifying that passport is valid via verification of a signature, and you're proving that verification in zero knowledge, right? So I think to me, like, that's an example of how you can have these composability with outside systems, using zero knowledge.
I think great minds think alike. We have an external project team working on a similar thing for ASIC zk passport. Just to reemphasize what Alex said, because I think it's going to be paradigm shifting. So yeah, passport, modern. God, Jesus Christ. Passports. Yes. The original non-fungible token.
Don't worry.
These things have chips in them, modern ones that, if you bring it next to your phone, you can, using RFID, your phone can trigger a digital signature to be signed. You verify that it's a knowledge proof. Ta-da, you've got some mostly permissionless way of verifying your identity. This extends to things far beyond passports. You can even use like bank cards as a very primitive form of ID. Again, prove someone has a US or UK bank account, or at least they have a card that does that.
Yeah, anything cryptographically signed can be verified in this model, which I think is really cool. I think people are just starting to scratch the surface of what you can do there.
Yeah. I can give another...
I want to ask something actually to Sandy. Because actually, I want to focus on... This is the good part, which is let's talk about actually what interesting things we can build, and now that we actually have the infrastructure ready. 1 month in to the mainnet, how are things going? What are some of the coolest things you've seen so far, or even people that are working on them, and that you think will kind of be impressive to everybody else in the audience?
Yeah, that's a great question. I think after the first week of launch, we got to a stage where I'm not aware of everything that's on Scroll now.
Which is a pretty good problem to have.
So I get told all the time that, there's this project and that project. And so I don't have full visibility. But there are a few things that I think are quite cool that are coming or almost here or have been running for a while. There are a few kind of AI bot enabled kind of chat bots that are happening on chain that are helping people learn to work their way through our documentation. And there's this like negotiation game where you can negotiate against a Sam Bankman-Fried kind of character. And for your salary, that's hilarious. And there's a lot of there's a few projects from Turkey actually that I want to give a plug to. So there's a NFT marketplace called Cheese Art, and then there's a few wallets, and we're looking to support more and more projects from Turkey. And I think of the ones that I think are zk interesting, there are a few kind of zk applications that are working on the more established blockchain use cases that I'm aware of, that I'm expecting will get quite a lot of traction from the existing players in the ecosystem that already has found a business model. So there are super fast kind of L3s using zero knowledge proofs on Scroll that's coming soon. And then there's a order book DEX, which is also a very well established kind of DeFi primitive using zero knowledge proof. It's also an L3 using this where we're sharing the provers, and it's going to be probably faster than certain kind of order book DEXs that recently went to Cosmos. And And I think there's there's an L3 that is working on like selective privacy disclosure for institutions. Apparently, institutions have given them feedback that sometimes they want full privacy, sometimes they want to be fully transparent on chain, sometimes they want to be a little bit in between. And I think there's a project that's kind of working on some like tailor-made solutions, but these are kind of the early shoots that I'm keeping an eye on.
Awesome. For Aleo, I know there's been a lot of experiments around just kind of data computations. Anything that you're able to share on what's kind of super interesting to you personally that you've seen on the network?
Yeah, I mean, I guess the first thing I'll say is like I'm really excited and proud that we're finally at the point where the network is going to be live in January. I think it's already actually mostly live. So the only part of it that's not permissionless is the consensus. We've only got about, I think, half of the validators are external and half are internal. But yeah, I think right now, people are to Sandy's point, people are deploying things all the time on this, and I'm kind of only dimly aware of all the activity. I typically find out after the fact. But yeah, the use cases that I'm personally most excited about are the identity type use cases. And then that I think, to me, that is an essential precondition for building payment applications that are both compliant and private, as in like actually usable in like the real financial world, right? So, like I said, ZPass is an example, of something that we built. Someone else took that, because ZPass is actually an SDK. Someone else has taken that and made basically an age verification tool for the web, which lets you filter content by if it's age restricted or not, which is cool. And then we're working with a team called named Archblock, which I think used to be TrueFi, and working with them to do a CBDC issuance for a country in the Gulf, which I think is a really early experiment, but I think it's really cool because to me, I think that's the biggest use case for blockchains are still financial. And I think a lot of the reason why we don't see more adoption there is it's transparent today, but even if you solve that problem, there's still concerns with compliance. And so I think the combination of being able to achieve compliance through whatever logic you want by a smart contract in a privacy preserving way, that's what gets me excited.
Nice. I mean, for a whole country as an experiment for issuance, that's not a small thing. So this sounds like very high potential.
But to be clear, it's early days for Aleo, and it's still early days for all of us. I mean, we've all been going to these conferences now for years, and like we're still not at the point where we've changed the world yet. And but the developments that have happened in zk certainly over the last 5 years. I mean, this better than me. I mean, it's as much as happened in the last 5 years as did in the previous 30. And I think that's the exciting part to me about the potential of this technology. And that's the common thread between all of us. And, it's going to take all of us, including everyone in this room, to actually push this and go beyond what's just a cool thought experiment and take it to something that really impacts real users.
I just want to make sure if somebody has a question in the audience, we'll have enough time to just do 2 questions. If you want to just line up, we'll kind of adjust the rest of the thing accordingly. But I have 1 question to go, but I'll let Zac answer that question too.
Thank you. Yeah, thanks. Yes, so I think we're very aligned here. Why is privacy useful? Privacy is identity. The sum of all your monetizable information is who you are. As in, that literally is in how every other organization, institution, perhaps even people will view you through that lens. And if you can have on-chain representations of your identity that are hidden, where you can prove statements about them, that unlocks, that once properly executed will change the world, because it will enable finally for on-chain assets to move, off-chain assets to move on-chain, and actually have digital representations of every single goddamn asset that exists, from mortgages to shipping certificates to dodgy automobile loans. And then we can actually start to create a global settlements layer for the world's assets. Not digital assets, it's assets. And that's going to change things. Where I think that something is often missed is that I think what we're doing with these privacy-preserving settlement layers is what they really are, is we are planting a seed whose roots will sink deep into the earth, where the actual on-chain settlements component of this zk composable privacy tech stack will be tiny, because there's so much more value that can be added by zk where you have the much smaller transactions that are much more vendor specific, application specific, that will eventually only bubble up, and eventually some of these will get settled on chain, but most won't be. To give an example of this, So I think Brian from X Park said it best. ZK enables composability across data silos, not just applications or Web3, just so the generic concept of a data silo. Let's say I've got a web service and I want some information about your Facebook account and you're willing to give it to me. Well, I could ask you to, send a ping request to Facebook via the API and you'll get back a JSON blob and you'll send it to me. I can't trust you though. Well, to be more accurate, I can't trust the software you're running. And also that data is going to be formatted according to Facebook's weird API that I don't know or don't want to reason about. What does ZK enable? It enables data transformation pipelines, where you can take information from one data silo and provably extract it by verifying DNS signatures, TLS, that kind of thing, and then transform that data into a different format that is suitable for consumption by the requestee. Just that basic primitive, it unlocks so much that we are currently missing. And yeah, I feel like we are on the cusp of some foundational changes in how we interact online and just how communication networks can be structured that are going to change things.
That is an amazing intuition around you effectively zero knowledge to let you get proof of any data, and you effectively abstract away the fact that I don't need to know where it is, and those cells are kind of broken. That's such a good way to put it. Well, in this case, let's end on something that you actually disagree on, potentially. Mainnet just launched for Scroll. Alex just announced that you're going to mainnet in January, which is a big announcement. Aztec is on its way to be up there sometime next year. What defines a successful mainnet launch? How do you define things being decentralized? How do you define things working? Is this the right approach? We've kind of seen some thoughts on this. So maybe I'll let Alex.
I guess this was directed at me.
Tell us. How are you thinking about your mainnet launch,
So
Alex?
the context under this question is, I made a comment about Scroll's mainnet launch specifically on Twitter around. I disagree with the framing of what mainnet means. Now, that comment was not meant to criticize Sandy or Scroll, and by the way, I've made similar comments about other L2s before, Starkware being most notable. It's not to criticize. It's more of to me, what makes this space, again, going back to what it defines a blockchain. Defines blockchain technology, what is the reason we're all here? It's this permissionless technology. It started with Satoshi Nakamoto, right? Satoshi Nakamoto's developed Bitcoin. Why was Bitcoin special? Well, because it's a peer-to-peer, it was peer-to-peer system for electronic cash, whatever the title of the paper was, right? And I think to me, that permissionlessness was one of the reasons. By the way, Bitcoin was preceded by about 40 years of attempts to make digital cash, right? And it took 40 years to get to that point. It was a hard endeavor. We've all talked about this endeavor for us as hard, right? Ethereum, to go from Ethereum 1 to Ethereum 2 took years, right? And I think, to me, I really want to make sure that we discuss these things and the terminology that we use reflects that difficulty and reflects the features that we should collectively agree on. This shouldn't be one person's opinion, and so this is why it should be a community discussion. But to me, my opinion is that, when we say mainnet and we talk about Ethereum as on mainnet, to me that means this is a permissionless network, right? I think you can deploy software on top of mainnets, but to me those are not themselves mainnets. So that's my personal view. And again, part of this is not just as a member of Aleo and I'm trying to score points on people. It's just as a member of the crypto community, because by the way, there are a lot of people outside of this room with a lot less scruples who say things are mainnet and say things have 1 million TPS and say things are privacy preserving. I mean, we see these announcements all the time. And sadly, it reflects badly on all of us, because when the person walking on the street out there hears about crypto, they might not hear it from you or me. They might hear it from one of those people. And then they get jaded by what this technology is and what it can and cannot do. And then they decide to write the whole thing off. And that, to me, is the outcome that I personally really want to avoid. And that's, to me, why I really push hard on making sure that we all, as a community, agree on and understand what the standards are for using certain terms.
So I want to applaud and also thank Alex for coming forth with standardizations about terminology, because I think out of almost everyone I know of in the industry, I think some would agree that Scroll has someone on our team who is very, very particular about terminology and insists on calling out other teams on these things. Just taking a step back for a second, I think Bitcoin is obviously, a fantastic project, and that's probably why we're all here. And it's great to kind of think about, how can we be more like Bitcoin in terms of our permissionless standards? But there isn't a single definition about what permissionless means. There's no standardization about what decentralization means. And there's also nothing about what security means either when it comes to, L2s and L1s for that matter. And for all of these, slightly amorphous terms to people of different kind of levels of technical understanding, there could be a huge range of what this actually means. And we all carry with it our own kind of assumptions and or our thinking into this. I think to step back is that no one can really get to Bitcoin's level of permissionlessness. When you think about any kind of permissionless standards, like you can't, if you're a human person, like we know Alex is a human being, then...
We hope.
Test. With an extremely high standard of mainnet definition. Essentially, for me, mainnet is a stage where any project feels comfortable enough to let their developers and let people external to the team interact with the chain. And when the block is produced, and when we feel like the security standards are at a level where we're happy to kind of present it to the world. And I think there could be, multiple layers of definitions about what this means, and you could, go into it about how, how L2's decentralization and security standards are hedged on L1, and about various training wheels. This conversation could be potentially endless, and I think on one hand, I do think every team should define their definition a little bit better. I think we definitely make regular attempts at defining certain terminologies, and but I think I think I'm all for a process where the team is being transparent and trying to get feedback from devs as early as possible, and also iterating on that feedback. So that's kind of where I stand philosophically.
That was amazing. I think that deserves an applause. Yeah. So maybe I'll give the last word to Zac. As Aztec v3 launches, how do you think about decentralization for your network?
How do we think about decentralization? All right, so
Let's watch him negate all those associate things.
Okay, I'm going to go on a very slight tangent, but I think it's relevant. Thank you. Networks have intrinsic values associated with them. What do I mean by that? Okay, so I'm going to lean into this Roman Empire meme. How many guys think about the Roman Empire all the time? So imagine, take the road network of the Roman Empire. If you showed an alien who had no contextual knowledge about humanity that road network, I would wager that they will be able to conclude that the culture that built that network was a hegemonistic, imperialistic culture. Why is this? Well, if you have a very advanced, well-developed set of roads, then that enables trade and commerce, but it also unleashes an enormous amount of potential instability, because it means that armies can now march down these roads very quickly, and it means they can launch hit-and-run attacks and sack cities very easily before reinforcements can arrive, which would then completely undermine the value of the road, so it wouldn't get built. Therefore, if you have a sophisticated road network that spans a large geographical region, there is only one army marching down that road network. So you can also tell that it's an imperialistic culture, because the road network has its beating heart at Rome, and then you have these arterial roads that are radiating out, but ultimately all roads lead to Rome. So you can see that network is also enabling a singular entity to project force and power from a single point. So now let's look at Aztec network's values. Aztec is when Aztec hits mainnet, we are going to be fully decentralized. By that I mean there's going to be no actor that can control the network or force upgrades. There's going to be no actor that can control who can interact with the network. It'll be completely permissionless. Anyone will be able to deploy contracts. Anyone will be able to send transactions. We will have strong guarantees against censorship attacks through having a fully decentralized sequencer network and a decentralized proving network. Well, these are bold claims, at least. I'm talking a big game. We'll see if I walk it. But I'm confident that we will not because of any values or ideologies I hold, but because the network requires it. Like Aztec as a network cannot succeed or survive or thrive if it is not fully decentralized from day one, for a variety of reasons that are relatively unique to privacy-preserving protocols. And so even though I haven't arrived at that conclusion through particularly ideological means, if I could launch centralized, I would. It's a lot easier. It would shorten our roadmap. But I can't because of the intrinsic values the network has forced upon me.
I think that's an excellent point to end this conversation. This was great remarks, and thank you so much for that thoughtful chat. Please give a big, massive round of applause for our three panelists, Sandy, Alex.
Hey, thank you very much, Kartik, for
Thank
hosting.
you.